unit 1, we talked about correlation coefficients and lines of fit. And we talked about how the closer those points are to our line of fit, the stronger the correlation. Now we're going to talk about what exactly is that space between the data point and the line of fit that we're looking at. That space or that value has a particular name, and it's called a residual. So our goal in today's very short section of notes is to identify what is a residual and how do we use it. So a residual is the difference, meaning subtraction, between the y value of a data point, so the actual y value, and the y value that we find using a line of fit. So say you had a set of data, as graphed here, there are 4 different data points. Say you had a set of data, and we used a line to approximate that data. We can tell how good of a line of fit this is based on the type of residuals that we have. And again, a residual is the distance between the actual data point and the line of fit. So if you look at this residual right here, if I go from the data point to the line, that's going to be a positive number. And that value, that difference, which in this case looks like, 1, 2, 3, that difference of 3 is called the residual. Similarly, over here, if I take my data point value and I go to that line, I'm below the line, that's going to have a negative residual of 2. It is 2 y values below the line. So residual, the difference between the y value, actually here, let's put a box around this, the actual y value of the data set minus the line of fit value, the line of fit that we are using to approximate it. Typically, a line of fit is calculated using a calculator to come up with the best line of fit. What we're going to do in this section is we're going to analyze a given data set and a given line of fit, and we're going to decide based on the residuals, which we're going to calculate, based on the residuals, is this a good line of fit? So before we can do that, we have to define what are we looking for with these residuals. So a good line of fit has residuals that are small numbers. I'm going to put that in quotations because we aren't really going to define what small means, and that are both positive and negative. So we want some points that would be above the line if we graph them, and some points that would be below the line if we graphed them. So when we are calculating residuals and we're looking overall at the line of fit, we want small positive and negative numbers. Now, if you looked at this green point right here, if I calculated the residual of this point, that residual would be 0. The line of fit y minus the actual y value would be 0. What does that mean? That means the point, the actual data point, is on the line of fit. The data point is on the line of fit if the residual is 0. So let's look at some examples here. So this x and y that are given here, actually let's do this on the other side. This is our data set. So let's say I was doing some sort of study, and these are the values that I got from my study. Now, what I'm doing is someone said, hey, I used a calculator to come up with this line of fit, y equals negative 3x plus 2. And they're asking us, is this a good line of fit? So what we need to do is we need to take all of the x values. So we're going to take every x value here, and we're actually going to plug in those x values into our equation. So we're going to plug x's into, in this case, y equals negative 3x plus 2 to find the line of fit y. That is going to go in this part of the table right here. We are then going to subtract our line of fit value from our y value. So we're going to do, after that, we're going to do y, the y's that are in the table minus the fit line y's to get our residuals. So the very first thing we're going to do, we're going to plug each of those x's, -4, -3, -2, -1, 0, 1, 2, 3, 4. We're going to plug each of those into our equation, y equals -3x plus 2. That's going to give us this part of the table here. Then we're going to subtract the actual y minus the fit line y to fill in our residuals. And then we're going to analyze, based on those residuals, is this a good line of fit? So I'm going to give myself a little bit more space so we can actually work through this problem. So if you didn't get anything over here down, go ahead and pause the video and unpause it when you're ready to work through the math on this problem. Okay, here we go. The first number I'm going to plug in is -4, and I'm plugging all of these numbers in here. So when x equals -4, y equals -3 times -4 plus 2. -3 times -4 is 12. 12 plus 2 is 14. So when x is -4, the line of fit y is 14. I'm going to do the same thing with -3 when x is equal to -3, y equals -3 times -3 plus 2. That's going to give me 9 plus 2, which is 11. When x equals -2, sorry, y equals -3 times -2 plus 2, which is 6 plus 2, which is 8. Why don't you go ahead and pause the video and work through the rest of the values in this table, just plugging each of these x values into your equation to find the y value on the line of fit. All right, so here is the table all the way filled in. Please pause the video and make sure you have all of those same values. And I showed all of that work over here off to the side for you to see those values when I plugged the x into y equals -3x plus 2. Now, the reason I like to use the table is because it makes this next step a little bit easier. So what we are going to do now to find the residual, we are going to take this y value minus the line of fit y value. So you're going to subtract up and down, old school style. So here I have 13 minus 14. That's going to give me -1 as my residual here. I have 11 minus 11. That's going to give me 0. That means that this point is actually both on the line and in the data set. I have 8 minus 8. That's going to give me 0. 6 minus 5 is 1. 3 minus 2 is 1. And here, I'm going to show you this one off to the side because a lot of people get messed up here. This is 0 minus -1. Remember that that's going to become addition. So this is going to become +1. Similarly, -4 minus -4 is going to give me -4 plus 4, which is 0. In the next column, I'm going to have -8 minus -7, which is going to give me -1 because that becomes addition. In the last column, -10 minus -10 is going to give me 0. So I'm going to erase this to give myself a little bit more space down here. But check over, make sure you understand those residuals are coming from the given, the y in the data set minus the line of fit y. So what were we being asked in this question? This question didn't say fill in the table. It said use the residuals to determine whether this is a good line of fit, whether the model is a good line of fit, and to explain. So again, we are looking for residuals that are small. All of these numbers are small, right? 1, -1, 0. Those are all small numbers. We're looking for numbers that are small and both positive and negative. Well, I have 2 negative numbers and 3 positive numbers. The other 4 values have a residual of 0, which means they're actually on the line. So this question is asking us, is this a good line? Got cut off there. Is this a good line of fit? And the answer to that question is yes, this is a good line of fit. And the reason it is a good line of fit is because the residuals are small and they are both positive and negative. They're pretty evenly distributed between positive and negative numbers. All right, we're going to do the exact same process one more time. So the very first thing I want you to do is I want you to take this line of fit, that's what we're wondering about, and I want you to plug in each of your x values to find your y values, your line of fit y values. So go ahead and pause the video and do that. So here are the values filled into the table, and the work is off to the right. So feel free, pause the video, check over that work, make sure you're getting the same values in your table that I got in my table. And now we're going to calculate the residuals. So we are going to subtract the actual y value minus the line of fit y value. So 2 minus 1 is 1, 0 minus 1/2 is negative 1/2. Negative 3 minus 0 is negative 3. Negative 5 minus negative 1/2 is going to become plus. So negative 5 plus 1/2 is going to be negative 4.5. Negative 7 minus negative 1, that's going to become negative 7 plus 1, which is negative 6. Negative 6 minus negative 3 over 2, again, this is going to become addition. That's going to give us negative 4.5. Negative 4 minus negative 2 is going to give us negative 2. Negative 3 minus negative 5 over 2 is going to give us negative 1/2. And last but not least, negative 1 minus negative 3 is going to give us 2. So I'm going to erase this work so I can talk about whether or not this is a good these residuals make a good line of fit. So when we are looking to decide if residuals make a good line of fit, we want about an even number of positive and negative numbers, which we do not have in this case. Most of these are negative numbers, all but it looks like 2 of them. We're also looking for them to be small numbers, and we have some small numbers, but then I see a negative 4.5 and a negative 6. So I would say, no, this is not a good line of fit. Since most residuals in this case, most of the residuals are negative, and the numbers aren't small. So wrapping up today's lesson, a residual is the difference between the y value of the data point and the y value that you get when you plug your x's into the line of fit. In order to have a good line of fit, we're looking for residuals that are both smaller numbers and have about an even distribution of positive and negative numbers. And that's what helps us decide if a line of fit is a good line of fit. Looking forward to supporting you on this in class. Thanks for listening.